At 6:15 local time, a group of 15 Ukrainian drones raced across the Gulf of Finland toward Ust-Luga, Russia's deepest, largest Baltic port. It was so heavily defended that the Russians called it untouchable. After flying 960 kilometers through the night engines, running hot and fuel gauges dropping toward empty, everything still seemed normal. Then, a Russian patrol materialized through the morning fog. The formation leader suddenly jerked hard right as tracers erupted from below. A Russian patrol boat had spotted them, its 14.5mm machine gun walking fire across their flight path. Rounds passed between two drones close enough that human pilots would have felt the pressure waves. But these had no pilots, only operators watching grainy satellite feeds from bunkers near Kiev. 3 Igla-S missiles launched from the patrol boat weapons meant for helicopters now fired desperately at shadows in the dawn light. The drones scattered like startled birds, some climbing, others diving to wave height. One missile lost lock completely and spiraled into the Baltic. Another exploded harmlessly between targets, its proximity fuse triggered by empty air. The third found its mark, turning the trailing beaver into a brief fireball that scattered across the water. 14 survivors regrouped and pressed on toward Ust-Luga, now just 40 kilometers ahead. That was when the S-400 battery lit them up. The S-400's gravestone radar had been tracking them for minutes, but only now revealed itself switching from search mode to targeting mode. These were not commercial quadcopters. These were UJ-26 Beavers, purpose-built weapons that could make even Russia's most advanced surface-to-air systems struggle. The Russian radar operator was about to learn why his trillion-ruble air defense network feared these $35,000 drones. As soon as the Beavers came within range, the S-400 began painting them with radar energy. The system works by emitting a focused radar beam around 3 GHz and measuring how the signal bounces back. It is like sonar, but with radio waves instead of sound. The problem was material. These Beavers were built from fiberglass and carbon fiber, which reflect only about 10% of the radar energy compared to metal aircraft. At 40 kilometers, they appeared smaller than seagulls on the screen. The operator could not get a solid lock, so he tried something clever. He ordered a track-via-missile engagement. The idea was to use the missile's own seeker to relay better targeting data back to the battery. 2 48N6DM missiles erupted from their launchers, each worth about $2 million and designed to destroy $100 million fighter jets. Physics, however, was on Ukraine's side. The drones immediately dove to 10 meters above the Baltic waves. The missiles tried to follow diving at 70 degrees. At that angle, their control fins, which act like small wings, lost effective airflow and stalled. Both missiles tumbled into the water. The S-400 crew switched tactics, launching 9 M96E2 missiles equipped with gas dynamic thrusters, tiny sideways firing rockets that allow sharp turns even without much airflow. These missiles were different. They could pull 60 Gs, turn almost instantly, and chase targets all the way down to wave height. The lead Beaver tried to evade banking hard left, but the missile computed an intercept point and adjusted instantly. 3 seconds to impact. 2 seconds. The warhead detonated, sending 200 tungsten fragments tearing through the air. The drone disintegrated into carbon fiber confetti. A second missile found another target. The debris created an unexpected problem for the defenders. 13 radar returns became hundreds as wreckage scattered across the sky, masking the surviving drones. The remaining 13 broke formation like rabbits dodging a hawk. Some climbed, some dove, some went left, others right. Russian air defenders had seen this tactic before. They had already positioned 4 Panzer systems in overlapping fields of fire, creating what they called a box. No matter which way the drones turned, they would eventually enter someone's engagement zone. The Panzers were built for this kind of threat, combining missiles for longer ranges and cannons for close-in defense, like a goalkeeper on a soccer team, the last line when everything else fails. Each Panzer used a different engagement philosophy than the S-400. Instead of firing multiple missiles at once, they followed a shoot-look-shoot pattern, fire one missile check. If it worked, adjust, then fire again. This maximized accuracy against maneuvering targets. The 1st Panzer locked onto a drone formation and launched a 57E6 missile at the leader. The drones immediately executed a wagon wheel maneuver, spiraling around a common center point while still moving forward. Imagine riders on a carousel that is also moving down a road. The constantly changing angles confuse the missile's proportional navigation system, which predicts where to intercept based on steady target motion. The Panzer gunner switched to his twin 30mm cannons capable of firing 5,000 rounds per minute. Instead of trying to hit individual drones, he created a beaten zone filling a cube of airspace with so much metal that anything passing through would be at serious risk. 4 drones entered this space. 2 emerged on the other side. The math was brutal and simple. 9 drones remained. Almost a dozen Russian missiles and hundreds of cannon rounds had been expended, and the drones had not even reached the port yet. Meanwhile, warning lights flashed across the Leningrad Oblast Command Center, showing similar engagements at Kursk, Bryansk, and Rostov. 14 other drone groups were attacking simultaneously across western Russia. Every air defense battery was already engaged. There would be no reinforcements. The Russian units here were on their own, so were the drones. The surviving drones pushed toward their target, knowing the hardest part was still ahead. The Krasuka 4 electronic warfare vehicle on the outskirts of Ust-Luga looked like a simple shipping container on wheels. Inside was about $20 million worth of jamming equipment. As the 9 surviving drones approached Ust-Luga, the system activated, flooding the electromagnetic spectrum with interference. Krasuka works by overwhelming radio frequencies with noise. It is like trying to have a phone conversation while someone blasts static into your ear through a megaphone. The system swept from 1.2 to 5.8 GHz, hunting for the control frequencies linking the drones to their operators 1,000 kilometers away in Ukraine. The Russian EW operators used a technique called sweep and dwell, rapidly scanning the spectrum to find active channels, then concentrating jamming power on those specific frequencies. Within seconds, they identified transmissions at 2.0 GHz. Krasuka focused its 20-watt beam, creating a wall of electromagnetic noise. But the beavers were not using simple fixed-frequency remote control. They were frequency hopping, jumping among 128 channels every second in a pseudo-random pattern only the Ukrainian side knew. It is like constantly changing phone numbers mid-conversation with only one person holding the schedule. In theory, this should have been impossible to jam. The Russians tried something else, barrage jamming, flooding the entire band with interference, regardless of specific frequency. The logic was simple. If you cannot find the needle in the haystack, set the whole haystack on fire. This should have severed all control links, but the drones kept flying. They had shifted to autonomous mode using terrain contour matching. They compared radar altimeter readings to preloaded topographic maps. Every hill-building bridge and tower had been mapped and programmed. The drones knew where they were without any external signals. Autonomy brought its own risks. 3 drones flew directly into a construction crane that did not exist when their maps were created 6 months earlier. The metal tower appeared suddenly in the fog, too late to avoid. Carbon fiber against steel is never a fair fight. All 3 drones were destroyed instantly. 6 remained, but their batteries showed just 18% charge left. The calculation became critical. They had enough power to reach the target, but none to spare for extra evasive maneuvers. They now had only 1 attempt. Meanwhile, the S-400 battery commander faced an ugly math problem of his own. His remaining missiles cost about $2 million each, designed to destroy aircraft worth 100 times that amount. The drones attacking his sector cost around $35,000 each. Even if he shot down all of them, Russia would be losing economically. This was not just warfare. It was economics with explosives. He ordered his crews to switch to Zu-23 anti-aircraft guns, twin 23mm cannons, designed in the 1960s. The ammunition was cheap, only a few dollars per pound, and a hit from one shell had the same effect on a drone as a multi-million-dollar missile. The problem was that these guns required optical aiming. Someone had to actually see the target. The drones flew at 150 kilometers per hour and executed random barrel rolls every 2 to 4 seconds. The targeting computer needed 3 seconds of steady motion to generate a proper firing solution. It never got that time. The gunners reverted to Second World War tactics, filling the sky with tracers and hoping something connected. One lucky burst hit a drone mid-roll, tearing through its fiberglass fuselage. 5 drones remained. Ust-Luga port was just 8 kilometers ahead. Real war, however, is not just about machines. Nature plays a role too. As the drones approached the port, the rising temperature caused the fog hanging low over the water to lift and thicken. The same fog that had shielded them now turned the area into a ghostly maze where million-dollar sensors became far less effective. Visibility dropped to 30 meters. Russian defenders could not see the drones. The drones could not see the port. Everyone was fighting blind. Panzer's thermal imagers, designed to detect heat through smoke and darkness, could normally spot aircraft at 5 kilometers. Fog, however, scatters infrared radiation just as it scatters visible light. Detection range dropped to about 200 meters. The defenders switched to area saturation, firing blindly at the approaches they believed the drones would use. They created walls of fire over specific GPS coordinates and bet the drones would fly through them. 5 Ukrainian drones descended to 3 meters above the water, their radar altimeters constantly pinging to avoid slamming into waves. Salt spray coated their camera lenses, turning any video feed into a useless blur. Operators in Ukraine saw only gray static through their satellite links. They were now flying purely on GPS coordinates, trusting math to carry them toward Ust-Luga's gas complex. Frustrated at the lack of confirmed kills, Russian crews activated GPS spoofers, broadcasting false position signals from powerful ground transmitters. This works by overwhelming weak satellite signals with stronger fake ones, tricking GPS receivers into thinking they are somewhere else. It is like your car's navigation suddenly insisting that you are driving in another city. 2 drones obeyed the fake coordinates, banked hard right, and flew directly into the water. The splashes were invisible in the fog, revealed only as brief blips on radar that vanished instantly. 3 drones remained. Their backup inertial navigation systems kept them approximately on course despite the GPS lies. Port security forces armed with Igla-S shoulder-fired missiles waited on rooftops and towers. The Igla's seeker uses a nitrogen-cooled detector sensitive to wavelengths between 3 and 5 microns. Human eyes see in a different band. The Igla sees deeper into infrared, picking up temperature differences as small as half a degree. The Beaver's small 20-horsepower engine, however, ran only about 40 degrees above ambient. Against the warm Baltic fog, It was nearly invisible. Troops fired ambush shots, waiting until they heard the drone buzz overhead, then shooting from behind where the exhaust heat was strongest. One missile found its mark, its proximity fuse detonating 5 meters from a drone. Shrapnel tore through composite skin and control lines. That drone spiraled into a storage tank farm. 2 survivors pressed on, weaving between 40-meter-tall petroleum tanks. An Mi-8 helicopter thundered overhead, door gunners firing PKM machine guns at shadows. The pilot tried to use rotor downwash to slam the drones into obstacles, creating 60-kilometer-per-hour winds that could blow them off course and into steel. The downwash also had an unintended effect. It cleared patches of fog. For a few seconds at a time, the drone's cameras could briefly see. The operators finally caught glimpses of their true objective ahead, the huge cryogenic processing complex. The facility's safety systems detected unplanned aircraft approaching. Threat assessment software, normally meant to prevent accidental collisions with commercial planes, triggered emergency protocols. Sirens wailed. Emergency venting began releasing thousands of cubic meters of methane and ethane to prevent catastrophic overpressure if tanks were damaged. That invisible cloud of flammable gas spread across the facility, waiting for any ignition source. The defenders had unwittingly created the perfect fuel-air bomb. Water cannon trucks raced into position. Their operators tried to knock drones out of the sky with high-pressure streams. These were not simple fire hoses. They were industrial systems powerful enough to punch through wooden walls at 50 meters. One drone flew directly into a water jet. The force snapped its propeller, and the drone crashed onto concrete warhead, intact but useless. The last beaver adjusted its course. Its thermal camera finally locked onto the unmistakable signature of the cryogenic processor, glowing at minus 163 degrees Celsius, colder than anything else in the port. The operator switched to manual control over an Iridium satellite link, accepting a 2-second delay that made precise flying extremely difficult at this distance. The drone had 12% battery remaining, perhaps 90 seconds of flight time. It traced a weaving path through the jungle of pipes and towers, each course correction burning precious power. Security forces fired rifles and shotguns toward the sound of its engine bullets sparking off metal structures. A pellet cluster shattered the camera, leaving the operator flying on dead reckoning and last known bearings. 10 seconds to impact. 5 seconds. Battery level critical motors beginning to lose power. Momentum, however, would carry it forward. The last beaver struggled through the refinery's 3-dimensional maze of pipes, towers, and catwalks. Its civilian GPS receiver, normally accurate to about 5 meters, showed errors of 30 meters due to multipath interference from all the metal. GPS spoofing signals grew stronger. The operator in Ukraine watched a crude telemetry feed over a low-bandwidth Iridium link. Altitude 3 meters, speed 40 kilometers per hour, battery 8%, target bearing 285 degrees. No clear video, no radar, just numbers updating every couple of seconds. The 2-second control lag made fine corrections almost impossible. By the time he commanded a turn, the drone had already flown 20 meters farther. He had to fly by prediction, imagining where the drone would be, not where it was like playing a video game where the screen shows what happened 2 seconds ago. Through occasional bursts of static, he caught fragments of images, a massive cylindrical tower pipes wrapped in silver insulation, warning signs in Cyrillic. This was the cryogenic fractionation unit, the heart of the complex, where gas condensate was separated into valuable products. Security teams deployed their last defense, more water cannons on trucks. One operator tracked the drone by sound alone, leading his shot as if hunting a clay target. The water stream caught the beaver's tail, spinning it violently. Its gyroscope fought to stabilize the motors, screaming at full power and draining the last of the battery. The readout flashed 5%. The operator knew he had one chance left. He pushed the nose down, trading altitude for speed, diving toward the base of the target. Emergency venting had already created a cloud of methane mixed with ethane and propane, a near-perfect fuel mixture waiting for a spark. The drone's 20-kilogram warhead contained thermite-enhanced charges, aluminum powder, and iron oxide that burn at over 500 degrees Celsius. Thermite cannot be extinguished by water or foam. Once ignited, it burns until it consumes its fuel hot enough to melt through steel. The warhead was set for impact detonation using a simple mechanical fuse that did not depend on electronics. 3 seconds to impact. The battery died completely, and the motors stopped. Physics took over. 40 kilograms of drone, traveling at 15 meters per second, still carried momentum. It glided the final 50 meters in near silence, a ballistic projectile obeying Newton's laws. Security forces held their breath, hoping it would hit something non-critical or fall short. The drone struck the base of the fractionation column, exactly where the operator had aimed, crumpling against the steel with a sharp metallic impact. For a heartbeat, nothing happened. Then the thermite ignited. The initial blast was small, more a brilliant white flare than a huge explosion, but in 2 seconds, it burned through the steel shell of the column. Superheated metal sprayed into the pressurized vessel, instantly vaporizing liquid hydrocarbons. The pressure spike ruptured nearby pipes, releasing even more flammable gas. Then, the vented cloud ignited. The fuel-air blast expanded at around 3,000 meters per second, a crushing overpressure wave that shattered windows across a 1-kilometer radius. A fireball rose 200 meters into the air, glowing orange against the morning fog. And that was only the start. The facility suffered a BLEV, a boiling liquid expanding vapor explosion. Pressurized liquefied gas rapidly depressurized, expanding hundreds of times its volume and creating enormous destructive force. Each ruptured vessel triggered failures in adjacent tanks, a chain reaction that consumed the entire complex in minutes. The $2 billion cryogenic processor, designed to survive storms and even earthquakes, collapsed into twisted steel. The fire burned for 6 days, visible to satellites, and from the Estonian border, a towering column of smoke marking Ukraine's deepest strike yet. Bye for now.